So let us, I hope all of us can see the R Studio. So we've done all this before. The starting point is usually you set your working directory. And let me set the working directory to AEM636. AEM636. So I've set the working directory. So the necessary packages, this is the ones that we've done before. You need gravity, tidyverse, correlation, ggplot for the previous one that we've done. And you need the data, and we are using gravity zeros. Then don't forget the way we remove all the rows where the trade flow is equal to 0. That's what we try to do here. We did that one in the last class, so I don't have a problem. Then here we select the 4 variables for our correlation. Then we perform the correlation analysis. Then we try to show the graphical representation, and that is what you have done, because most of you have actually submitted the assignment, and I could see so many of you did very well actually. You have not finished marking everything. So, and this is trying to teach us how to create data sets in case we want to look at one country or more than one country situations and so on. So now, but today we want to start with estimating the actual estimation of the gravity model. So you need this package, estimate R, ESTIMATR, estimate R, because we want to run a robust regression. The reason why we need to run robust regression is, you know, we are dealing with so many countries. In this case, in fact, almost all the countries in the world. So there are a lot of heterogeneity. You can't run away from it. So we are trying to control for the heterogeneity, heteroscedasticity, I mean, right from the beginning. So we are trying to ensure that we have the appropriate standard error through the use of robust regression. And to handle that one, the function is LM_robust. That function you can place in estimate R package. So if you don't have this package, definitely you will have to install it on your own. So to run the regression is very, very straightforward. Let's start with the base gravity model. The base is actually the flow, the trade flow, then the GDP, just like what I was trying to show us. The GDP of the country of origin, the GDP of the country of destination, then the distance. That's all. Then here, data, our data is the gravity non-zero, that is the gravity where we have removed the zeros. Then In order to control for possible multicollinearity between what is it called now? Distance and the other variables for because you are considering country of origin, country of destination pairs, and there could be a lot of that is why we include clusters here. Then the standard error type that we want the kind of standard error type that is in starter. So it's very straightforward. So let's run this. Run. Oh, sorry, let us run everything for name select so that, because even the data we have not, they are okay. Let's run it from, so I will explain. It's going to take some time. So that we have the data set and all sorts of things. Yeah. So we already have our data set there now. So now let me run this so that I know the result are already there, but let me run so that you see clearly what the result is all about. So here is the result. So you can now see that what we have here is GDP of country of origin, GDP of country of destination, then distance. And here we have our interest. Now you look at the probability here in order to know whether they are statistically significant. And if you look at this is far below 0.01, which means they are all highly statistically significant. Then you now come back here and think of the signs. You look at GDP of origin, we expect it to be positive, it is positive. We have GDP of country of origin, of destination, we expect it to be positive, it is positive. And we expect distance to be negative, and it is negative. But we must know how to explain clearly what this means. Because it's not just saying they are positive, or they are negative. No, you have to explain the magnitude too. Very, very important. Based on your knowledge of econometrics, you can interpret. Yeah.
So from what we did last week, we if I remember very well, we multiplied the GDP of the original country and that of the destination country. But yes, when we're estimating that, we are not multiplying them to come up with one variable. Yeah. One.
The reason why we did that, we are dealing with two-dimensional graph.
Okay.
So that is limitation. That is one of the limitations of graph. You know, when you are dealing with graph, most of the time it's difficult to draw three-dimensional graph. You understand it?
Okay.
So that's the reason why we multiply the GDP of country of origin and country of destination together against flow. You understand that? And that is
Yes.
why we still have to take, that's why we have to take distance also separately. Another way of doing that is that you can actually take GDP of country of origin against flow, GDP of country of destination against flow, distance against flow, and you draw 3 graphs. You understand it? But
yes.
yeah, but the reason why we are doing that is just we are limited by graph, dimension, by the dimension of the graph we are trying to draw. So, and that is the essence of moving forward to estimate the model itself. You see, that is the essence of estimating the model. So, and I believe in econometrics. If you are properly taught, they will have shown you the limitation of correlation analysis and scatter diagram. Yeah, that's if you are properly taught. So, but if you are not properly taught, then make sure you get good books to guide you, because at times university calendar may not allow you to be properly taught. Yeah. So this is so I hope it's clear now. So let us now do some interpretation. 1.22. Who wants to interpret that one for us?
So come again, Prof.
1.22. Someone to interpret it. You can see it now. 1.22. The coefficient of the log of GDP of country of origin. 1.22. Who is trying? I'm waiting for you guys. You must do the interpretation. Don't because if I do the interpretation for you, you may even forget. That's the truth. But if you do it for yourself, even if you don't get it by the time the correct thing is stated, then you will remember clearly.
Okay, let me try to interpret, Prof.
That's fine.
A 1% increase in the trade flow will lead to a 1.22% increase in the GDP of the country of origin.
Hey, you really tried, but you have explained it in a reverse order, which makes it to be wrong. The correct thing is a 1% increase. This is positive now. A 1% increase in GDP of the country of origin tends to increase the trade flow by this will be increase in trade flow 1.22%. Yeah. Did you get it?
Yeah.
You must get this, because this is the ultimate. This is what you will write in your thesis or whatever. Now, if you don't get it correctly, it's terrible. So 1% increase in GDP of country of origin, because we are looking at GDP _0 here, tends to increase the trade flow by 1.22%. But you got that one correctly, but you are trying to maybe say it in a reverse order. Let another person interpret GDP of the country of origin, the coefficient, which is 0.90. Who is doing that for us?
Let me try, Prof.
Yeah, please try.
A 1% increase in the GDP of the country of destination,
yes,
is associated with a 0.90% increase in the trade flow.
Perfect, 100%. That's good. Yeah, let another person interpret the coefficient of the log of distance, which is minus 1.52. Who is doing that for us?
Let me try, Prof.
Okay, try, yeah. Yeah.
I think it's a 1% increase in the distance.
Yes.
Tend to decrease the trade flow by 1.5%.
Yeah, that's good. So please take note because this is very, very important. You got it correctly. Yeah, that's okay. Then someone to interpret the R squared for me. The R squared is 0.63. 0.63. It means what? R squared of 0.63. Who wants to try that one?
Yeah. 63% of the trade flow is explained by the distance and the GDP of the country of origin and the GDP of the country of destination.
Fantastic. That's good. Yeah,
No.
that's good. Yeah, please take note of all these things because that is where the policy actually comes from. And that is what you are going to really sit down and be sure you know. So let's move forward. Now, we want to estimate the augmented gravity. We want to augment with border measures. So, and we are augmenting with border. This is contiguity, and this is language, and this is common currency. So those are just that's just the change. Every other thing remains the same. So we call that one reg 2. So let's run it. Yeah. So now, the first thing you will notice, you can see that your adjusted R squared increase. Previously, it was 0.63. Now it's 0.64. So which means the fit of your regression is actually improved by addition of the border measures, which means the border measures are very, very important to trade flow. Don't forget that. But to really now know the actual contribution, then you have to come back to the model and look at the coefficients. So contiguity, which is sharing the same land border, is 1.16 here. And you don't just go straight. No, this is unlike, but this is dummy variable. So how do you now interpret this and say 1.15? Because this is, and don't forget, you are running log of trade flow against contiguity. And that is where you have your 1.15. So how do you interpret this one now? The starting point is, you know, it is positive. That one is very simple to interpret for sure. So because, which means if you share the same border, definitely your trade flow will increase. So you trade more. But the extent at which you trade more, how do you now undo that one? Who wants to try? Anybody there? You want to try? Contiguity is one point. Okay, let me explain because yeah, I think it's a bit tricky. So what you do is you calculate the exponential because you first need to convert it. Because this is, you are running log against you don't log, remember, this is not logged. This is, you can't log this because it's 1, 0. Log of 0 will give you nonsense. But your trade flow is log. So you must first calculate the exponential to really know the actual number of times, the actual percentage of trade increase, for instance, that could be accrued to sharing the same land border. So if I do that one, yeah, that's exponential 1.16. I got 3.19. It's 3.19 here. So this is clearly showing that sharing the same border, that is contiguity, will increase my trade flow by, we increase the trade flow of the countries by what? 3.19%. Is that clear? Did you get what I've done? Because we have to do that for, we have to do that for common language, you do that for the common currency. Take notes. That's very, very important. So if you understand that one, every other thing is very, very simple. So another thing we try to do is we augment with policy variable, you know, just like what I was explaining when dealing with the theory. So we augment with policy variable. To augment with policy variable, we say our policy variable is RTA, that is countries with trade agreements. So, and that is what we have here. Look at it. So it's the same thing. The only thing we add is RTA. RTA means if I have trade agreements, 1, no trade agreements, 0. So it's straightforward. Every other thing is the same. There's there's no problem. So you run it here. So, and if you have done it, again, you look at it, you compare. The other one is 0.64. Let's look at, maybe there is an improvement in the fit. The other one is 0.642. You can now see that here is 0.6 646. So there is slight improvement in the fit, which means policy variables also contribute to trade flow, and you can now interpret the coefficient, but you don't interpret it directly because it's 1, 0. So you have to calculate the exponential and interpret it in terms of percentage contribution. That's very straightforward. So now we have augmented. We augmented with border measures. We augmented with policy variables. And now, to estimate theoretically consistent gravity model, so we have to include multilateral stress. So to include multilateral stress, what you are just trying to do is to include the dummies. These are so many dummies because we are dealing with so many countries. Dummies for country of origin and dummy for the country of destination. These dummies, addition of these dummies is what is called the country fixed effects. Are very straightforward. So this is what I was trying to explain the other time. And this could take some time because, you know, it's a very massive data set. So let's run it, and you see, the. So here you have to wait because it's massive. It's massive. I know. Oh, good. So the result is out. So and you want to really know, maybe the multilateral stress also is important to trade flow. You check the R squared. We can now see the R squared now jump up to 0.73. And this is showing a massive contribution. So, but there is no way you'll be picking them one by one. There are so many of them, I'm telling you. So, so because all the countries, you get the ISO of all the countries, LSOG of all the countries, and so on. So, but apart from looking at what the change on, apart from looking at the change in the adjusted R squared, you will see that the coefficient also will have changed. The contributions will have changed. So you still have to look at the changes in the coefficient of the GDP 0, GDP D, and whether it's, you can now see, previously distance was minus 1.51, now it's minus 1.61 and so on. So you have to look at the differences. And before, contiguity was 1.15, it's now 1. This, and by the time you calculate the exponential, you can see that the contribution in terms of various percentages now has changed by the addition of the multilateral stress. And it's very important, multilateral resistance. And it's always good to add the multilateral resistance. So this is theoretically consistent gravity model. So, and this is stage by stage, step by step. If you want to really undo, and you continue to now explain, and the implication, you draw your references based on your knowledge of your country, trade policies, and all sorts of things. And that's how to do it. Yeah. Any question?
Yes, bro.
Okay, yeah.
Since we practiced interpreting the dummy of 1, is it possible to interpret the dummy of 0?
No, excuse me. What is not that we interpret dummy of 1. That is not, dummy means 1 when the event exists and 0 when it doesn't exist. It's still the same variable. So, but at the end of the day, when you estimate it, you get a coefficient. It's the coefficient of the variable that we interpret. You didn't get it. Let's go back to this place. Let's come back here. You see what I'm trying to say. Here you have, hey, let me go up. So like in this case, you have contiguity, which is sharing land border. Sharing land border, the coefficient here is 0.92. So it's a dummy variable. 1 if you share land border, 0 if you don't. So it's the same variable that you have measured. But when you run the regression, you have these coefficients. So when you have these coefficients, this is showing you positive contribution for a start without even looking at the magnitude. This is actually showing you that if I share land border with you, my trade flow will increase. That's clear because sharing land border is 1. So if I share land border with you, it's going to be my what is it called? Trade flow will increase. Or if you want to look at it from your 0 angle, if I don't share border with you, know that if I don't share land border with you, then my trade flow will decrease. Do you get it now?
Okay.
Yeah. If you want to look, but definitely you interpret it in terms of what exists.
Oh,
yeah,
okay.
which is 1 in your own case now. So interpreting in terms of what exists, that is, there is a land border. It means if I share land border with you, which is because that is the value we use, then my trade flow will increase. But it's going to increase by exponential of this. You can't just say increase by 0.9%. It's going to be wrong. So you calculate the exponential, exponential 0.92. So if I run this, so it is going to increase by 2.51%. That is the correct thing. So sharing land border increase the trade between the countries by 2.51%. That is how to interpret it.
So if it was negative, we could have said it decreased. Then what would be the other one? Then will it mean that it's positive, the 0?
I don't know. Oh, no, it's okay. Let's try and see if we have something that is negative, and we look at it. Okay, let's look at this ISO 0 whatever. So in this case, the negative is already telling me that Armenia, that is Armenia as a country, that if I come from this Armenia, trade flow will decrease. You understand that? Because coming from this is 1, not coming from that is 0. That's it. that is what that means. So belonging to this country definitely decreases trade flow. That is negative. But you can't say it decreases by 1.15. You can't do that. So you will come here and still say 1 point. So you can see now by 0.332%. You have seen the way I've done it. This is the same value that I calculate the exponential minus, and the minus is actually showing that there is a decline in trade flow. Yeah.
Okay.
Yeah, with that country. So there is a decline in trade flow with that country, definitely, by this percentage. Sure. Yeah. So it's clear. But definitely, I don't expect people to now begin to, unless unless you are dealing with very few countries or you have specific interest in certain country. Yeah, because it could matter. For instance, now, if you are dealing with SACU or you are dealing with SADC, I will want you to interpret the coefficient of South Africa, because South Africa is the main hub for trade within the region. So I want to look at what the coefficient of South Africa will be in the panel regression. Yeah. So any other question? Any other questions? So in case there is no other question, we have exhausted the 1.5 hours stipulated for this class. And for people that join late, I want to repeat what I said. I want to repeat what I said at the beginning. We have two major lectures to round up. One is impact evaluation, and that's very important. And the other one is market integration. We'll look at how to quantify impact evaluation and how to quantify the market integration, how to measure them. So we'll do quantitative analysis of impact evaluation, quantitative analysis of market integration. Those are the two that we need to do. Then we are going to have 2 tests within the week. The first test will be on Wednesday. We will meet on Tuesday for lectures, but on Wednesday we are meeting for tests. And your test, the first test will cover trade policy. So it's limited to trade policy analysis. So it's going to cover theory and practical, including what you learned today. That's very important. Then on Thursday and Friday, we would lectures, and you will have your final test on Saturday. And that test will cover impact evaluation and market integration analysis, which we are going to learn within that week. Every other things we have learned, we have covered in the various assignments. And what I'm going to do, pick 2 of your assignments, and those 2 tests are very important because it's part of the university regulation to form your CA, which we account for 50% of your grades. And I can assure you, if you pass the assignments and you pass the test, relax, you will pass the exam. I'm sure of that. But if you fail, my advice is please go over them very, very well and make sure that by God's grace, before Saturday, hopefully, I will let you know what you score in the assignments. But all of you passed, at least based on what apart from the last one, all of you did very well. So, but I expect you to do well also in the test so that at least you have a peace of mind concerning your exams. And that's very, very important. Please take note. Now take note of all this that I've taught you, because you have a very large class. And I know by the time you guys start your projects, some of these things will be very useful for you. In case there is no other question, I want to end the class now. So, thank you very much. Till we meet on Tuesday.
Thank you.
Yeah, bye-bye.